There is a nice little idea involved in this integral. Okay, so we have this integral from 0 to 1 by 2 ln of 1 plus x ln x by 1 x dx. Now, first of all, of course, thing that would simplify the integral is to convert this ln into a sum, since the x values lies in between 0 to 1 by 2, which is of course less than 1. And after that I will show an idea which quickly simplifies the problem. We have integral from 0 to 1 by 2, and now its sum representation, or Taylor series representation, is sum going from n to infinity of minus 1 to the power n plus 1 x to the power n divided by n. Yes, and over here we have ln x by x dx. Next, we will integrate the sum and integral and take the constants out of the integral. So we will have sum from n equals to 1 to infinity of minus 1 to the power n plus 1 by n, and integral from 0 to 1 by 2 of x to the power n minus 1 ln x dx. Now at this point I will show you something that will be really helpful while solving the problem, and that something is, let's say in the cases where we had integral from 0 to 1 x to the power p ln x to the power q, in this case this was an standard integral which could be solved using the gamma function, and its solution was minus 1 to the power q gamma of q plus 1 by p plus 1 to the power q plus 1. Yes, but over here in the integral that we have, it's slightly different, because over here the limits of integral are not from 0 to 1, but they are from 0 to 1 by 2. So yeah, so it will be slightly different. You can also use integration by parts if you want to, but yeah, integration by parts also works, because ln x and then its integral minus 1 by x and its integral, that also work. But I want to show you something that makes it even more simpler. So sum from n equals to 1 to infinity of minus 1 to the power n plus 1 by n. You can write it as partial derivative with respect to n of integral from 0 to 1 by 2 x to the power n minus 1 dx. Yes, now this way it will be more simpler. Now we have sum from n equals to 1 to infinity of minus 1 to the power n plus 1 divided by n, and partial derivative with respect to n of x to the power n by n evaluated from 0 to 1 by 2. Yes, and next is, this is sum from n equals to 1 to infinity minus 1 to the power n plus 1 by n. Yes, and over here this will just be 1 by n times 1 by 2 to the power n minus 1 by n times 0 to the power n. Yes, so this is basically sum from n equals to 1 to infinity of minus 1 to the power n plus 1 by n, and then partial derivative with respect to n of 1 by n 1 by 2 to the power n and minus 0, and minus 0 is not necessary to be written. Yes, okay, now we can differentiate this, and we know, you see that it's a product, so just use the product rule. Yes, u v dash plus v u dash, and if we use the product rule, we get the following expression. We get 1 by n, and then 2 to the power minus n times ln of 2, and using the chain rule we also have minus 1 over here. Yes, and next is in plus. Now we will differentiate 1 by n, which is minus 1 by n square, and 1 by 2 to the power n as it is. We can take the minus 1 common, and multiply it over here, and that gives us sum from n equals to 1 to infinity. Now minus 1 to the power n by n, and this thing over here has become ln 2 by n 2 to the power n plus 1 by 2 to the power n dot n square. Yes, now next is, let us try to write it together. Sum from n equals to 1 to infinity. Now this thing over here will be minus 1 by 2 to the power n by n square, and then ln of 2. Yes, plus sum from n equals to 1 to infinity. Now this will just be minus 1 by 2 to the power n divided by n cube. Now we know that LIP of x, this function is just defined as sum from the n equals to 1 to infinity of x to the power n by n to the power p. Yes, so that's why this is just ln2 times li2 of minus 1 by 2 plus this is just li3 of minus 1 by 2. Now already a lot of mathematicians have done a lot of work in finding these li values, and of course you can go search them and substitute. Yes, and yeah, this is the answer. ln2 li2 of minus 1 by 2 plus li3 of minus 1 by 2. And yeah, we have beautifully solved this problem. To summarize the solution, first of all we use the Taylor expansion of L1 plus x, and then we try to use the partial derivative and integrated and again differentiated and use the product rule and identified the sum as the Li function, and we got the solution. So this was it. Hope you enjoyed the solution. Thanks for watching and look forward to seeing you in the upcoming videos too.